Okay, we already set up the environment for the stream. So I think we're gonna continue. We're gonna continue on our CCNA progress. I'm gonna move up the audio audio output capture just a little bit for just like minus 20 dB. Cek 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 1 2 3. Cek 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 1 2 3 1 2 3 1 2 3 1 2 3. Cek 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 1 2 3 1 2 3 1 2 3 1 2. Bisa bang. Cek 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 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 cek 1 2 3 1 2 3 1 2 3 cek. Bisa nggak ya? Bisa nggak ya? Tol. 1, 2, 3, 4, 8, 9, 10, 11, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 12, 1, 1, 2, 3, 4, 5, 6, 7. Cek 1, 2, 3, 1, 2, 3. Cek. Cek. Cek 1, 2, 3, 1, 2, 3, 1, 2, 3. Cek. cek cek 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 menurunkan cek cek 1 2 3 1 2 3 cek pas lah sini sampai ini cek cek 1 2 3 1 2 3 cek and for the cek 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 1 2 3 1 2 3 cek cek cek
Right back.
cek cek we're gonna continue on cek cek 1 2 3 1 2 3 cek cek cek
Right back. Correctly configured in areas.
cek 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 1 2 3 1 2 3 cek 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 1 2 3 1 2 3 cek cek udah saya lakukan di minus di 125 ya komennya buatnya kita bikin ke 5 apa namanya cek cek area get RMS size 5 ms 5 ms 5 ms 5 ms 5 ms RMS nggak bisa nggak cocok nol koma lima cek 1 2 3 2 cek 1 2 3 cek 1 2 3 cek 1 2 3 cek 1 2 3 cek 1 2 3. Naikkan sedikit thresholdnya ke arah suara pelan Anda agar bising konstan di bawahnya teredam. Gerbang suara naikkan sedikit thresholdnya ke arah suara pelan Anda agar bising konstan di bawahnya diredam secara konstan bahkan saat gerbang suara dibuka. N20 yang kita tarik memang agak ini susah sih sebenarnya. Downward expander. Cek 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 just here in my noise floor dengan listrik yang tebal secara konstan. Sound cardnya tidak dikecilkan. Turunkan knob gain fisik di sound card audio link. Oke. Cek 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 1 2 3 cek 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 1 2 3 1 2 3 cek. Naikkan wet. Cek 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 1 2 3 cek. Cek 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 1 2 3 cek 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 1 2 3 cek 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 1 2 3 cek 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 1 cek cek 1 2 3 cek 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 1 2 3 cek 1 2 3 cek 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 1 2 3 cek 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 1 2 3 cek. Segini aja lah. Kayaknya besar kali soalnya nanti.
Akhirnya mulai
spooky season
Spirit Veil
and keep it
is 0. So all 4 routers will become OSPF neighbors. Here's a summary of those 3 rules. Of course, I will cover many more points about OSPF in the next few videos. I will go in depth about OSPF neighbors, OSPF LSAs, and other points. But now let's cover some basic OSPF configurations, so we can practice them in the lab video. So let's use the
Cek
same
1 2 3 cek 1 2 3 cek.
EIGRP, since you're already familiar with it.
Enggak kubus.
Although it's important that you understand those rules and terms about OSPF areas, for the CCNA, you only have to configure single area OSPF. So all of these router interfaces are in OSPF area 0. I've already configured R2, R3, and R4.
Cek
let's
cek
configure
1 2 3
OSPF
cek.
on R1. Here is the basic OSPF configuration. Let's walk through it. First up, to enter OSPF configuration mode, you use the command router OSPF followed by a process ID. A router can run multiple OSPF processes at once, and this ID is used in the router to identify each of them. Typically, you'll just use a single OSPF process, so don't worry about this number. I chose to use 1. If you remember the EIGRP configuration, you use the command router EIGRP followed by an AS number. For EIGRP routers to become neighbors, their AS number has to match. However, the OSPF process ID is different. The OSPF process ID is locally significant. Routers with different process IDs can become OSPF neighbors. Usually, I just use process ID 1, but you could, for example, use process ID 1 on R1 and process ID 2 on R2, and they would still become OSPF neighbors and exchange LSAs. Note that this process ID is totally unrelated to the area. You'll see next that the area is configured separately. So next, I attempted to use the network command just like I did in EIGRP. Note that OSPF uses wildcard masks, just like in EIGRP. If you need to review them, go back and watch Day 25's video. Basically, it's an inverse subnet mask. Anyway, I tried to use that command, but then the router says incomplete command. That's because the OSPF network command requires you to specify the area. So I activated OSPF on all of these interfaces in area 0. Once again, for the CCNA, you only need to configure single area OSPF, and usually you'll use area 0. For single area OSPF, it's actually possible to use any area number, but it's considered best practice to use area 0. Before moving on, let me
Wait a
review the
second.
function of the network command. It's just like in
Tar. Check.
RIP and EIGRP. The network command tells OSPF to look for any interfaces with an IP address contained.
So in this basic OSPF configuration, we're already seeing that we had 4 routers. So we configure router 1 first. So it has the neighbor IP address that says 10.0.12 and .13, and then the 172.16.1.0/28 that you can configure here. So the commands is network, IP, network, and the network, and then the wildcard mask. So the wildcard mask that .3 is /30. It's just because /30 has 255.255.252 minus 255 that equals .3. So with the /28 you will get 255 minus 15 equals 240. So the subnet mask of /28 is 240. That's why you use the wildcard mask .15 in array 0 here. So the router OSPF, you want to assign this command to configure OSPF.
In the range specified in the network command, and then activate OSPF on the interface in the specified area. For example, in the first network command, I specified 10.0.12.0 with a /28 wildcard mask in area 0. R1's G00 interface has an IP address of 10.0.12.1, which is contained in 10.0.12.0/28. So OSPF will be activated on G00 in area 0. When OSPF is activated on the interface, the router will then try to become OSPF neighbors with other OSPF activated neighbor routers. In this case, R1 will become OSPF neighbors with R2 and R3. I'll explain that process in depth in the next video. So just remember that the network command is simply used to tell the router which interfaces to activate OSPF on. It doesn't tell the router, advertise these networks. But we already covered that in the last video. Is simply used to tell the router which interfaces to activate OSPF on. It doesn't tell the router, advertise these networks. But we already covered that in the last video. Now let's look at a few other configurations you can do in OSPF. First up, the passive interface command. You already know this command from RIP and EIGRP. it's totally the same for OSPF. The passive interface command tells the router to stop sending OSPF hello messages out of the interface. OSPF uses hello messages to tell other routers about itself. Wait for day 27's video for more details on that. However, the router will continue to send LSAs informing its neighbors about the subnet configured on the interface. So, although R1 won't send hellos out of G20 and try to find OSPF neighbors, it will still tell its other neighbors about the 172.16.1.0/28 network. You should always use this command on interfaces which don't have any OSPF neighbors. It's a waste to continuously send hello messages out of an interface with no other routers connected to it. So that's the passive.
So the passive interface that, as you can see here, is used for the interface that have no neighbor that connected to its network. So for this instance, G0, G20, 172.16.1.0/28 has no neighbor to send and inform and exchange LSS with its network. So stated here, you should always use this command on interfaces which don't have any OSPF neighbors. However, the router will continue to send LSAs informing its neighbor about the subnet configured on the interface.
Passive interface command. It's basically the same as for RIP and EIGRP. Next up, let's see how to advertise a default route into OSPF, just like I showed you before for RIP. So I've added an internet connection to R1. Then I configured a default route on R1, and the next hop is the ISP's IP address of 203.0.113.2. Here is that information in the routing table of R1. Feel free to pause here if you want to check out the other OSPF.
Static default route, IP route. Okay.
Routes that R1 has learned too. Just like I showed you in RIP, the command to advertise the default route into OSPF is default information originate. In OSPF, this will cause the router to create a new LSA and flood it. I checked R2's routing table, and you can see it added the default route via R1 to its route table. R3 and R4 would also do the same. Now let's take a look at the show IP protocols command from an OSPF perspective, and we'll check out some other commands as well. Up top it says routing protocol is OSPF 1. 1 is the process ID I configured earlier. OSPF also uses a router ID, and the router ID is determined in exactly the same way as an EIGRP. Let's review it. Here is the order of priority when determining the OSPF router ID. First up, if you manually configure the router ID, that will become the router ID. If you don't manually configure the router ID, the highest IP address on a loopback interface will become the router ID. If the router has no loopback interfaces with an IP address, the highest IP address on a physical interface will become the router ID. Currently, R1's router ID is 172.16.1.14 because I haven't manually configured the router ID, and I also haven't configured a loopback interface on R1. Let's see how to manually configure the router ID. From OSPF configuration mode, use the router ID command. This is a little different from EIGRP. In EIGRP, the command is EIGRP router ID, but in OSPF, it's just router ID. So I entered a router ID of 1.1.1.1, but then the router displayed this message. Reload or use clear IP OSPF process command for this to take effect. So currently, the router ID is still 172.16.1.14, To make 1.1.1.1 take effect, we have to either reload the router or use that command to clear the OSPF process and reset it. I did that. From privileged exec mode, I used the command clear IP OSPF process. This basically resets OSPF on the router. This is a bad idea in a real network, and the router will lose all of its OSPF routes for a short time and won't be able to forward traffic to those destinations. In a lab like this, however, it's not a problem. As a side note, notice the no in square brackets. When you see this after entering a command, it means no is the default choice. If you just press enter, the router will assume no and not clear the OSPF process. However, I typed yes, so it was cleared. Then I did show IP protocols again, and you can see that the router ID is now 1.1.1.1. Now let's look at the rest of the command. Take a look here. It is an autonomous system boundary router. An autonomous system boundary router, or ASBR, is an OSPF router that connects the OSPF network to an external network. R1 is connected to the internet. By using the default information originate command, R1 becomes an ASBR. It connects the OSPF network to the internet. So that's why we see this output here on R1. Next up, number of areas in this router is 1. 1 normal, 0 stub, 0 NSSA. These are 3 different types of OSPF areas. It's not necessary to know about the different types for the CCNA. Just wanted to point out that you can see the number of areas this router is in. Just 1, because this is single area OSPF. Next, maximum paths is basically it's an inverse subnet mask. OSPF configuration. So just remember that
have no neighbor that connected to its network. So for this instance, G0, G20, 172.16.1
is 4. Unlike EIGRP, OSPF doesn't support unequal cost load balancing, but it does support ECMP load balancing over a maximum of 4 paths by default. To change the maximum number of paths, use the maximum paths command, just like in RIP and EIGRP. Here I changed the number to 8. The routing for network section shows the network commands we used. To repeat myself, this only determines which interfaces OSPF will be activated on. It doesn't tell OSPF to flood LSAs for these specific networks. Here's the passive interface we configured, and here are the paths command. Just to repeat myself, this only determines which interfaces OSPF will be activated on. It doesn't tell OSPF to flood LSAs for these specific networks. Here's the passive interface we configured, and here are R1's neighbors. Notice the router IDs. I configured these loopback interfaces on R2, R3, and R4, and their IP addresses became the router IDs. Finally, down here OSPF's AD is displayed. The default is 110, as you know. If you want to change it, the command is the same as for RIP and EIGRP. From OSPF configuration mode, just use the command distance. For example, I changed it to 85, so OSPF routes are preferred over EIGRP routes on this router. That's all for the lecture. We covered a lot of information, but lots of it is similar to or the same as what we learned about RIP and EIGRP. Of course, there was plenty of new information too. Before moving on to the quiz, let's review what we covered. I gave a basic overview of OSPF operations, including a very brief look at LSAs, which we will cover in more depth later.
Here in my heart, there's
Although the CCNA only requires you to configure single area OSPF, you still need a basic understanding of OSPF. Make sure to remember those basic OSPF rules and terms like area border Autonomous System Boundary Router, ASBR. Finally, we looked at some basic OSPF configurations. Most of these were the same as in RIP and EIGRP, with a few minor differences.
Basic OSPF
Make sure to watch until
configuration.
the end of the quiz for a bonus question from Boson XSIM for CCNA, the best practice exams for the CCNA, and the ones I used myself to prepare. If you want to get Boson XSIM, follow the link in the video description. Here's quiz question 1. Which of the following statements about OSPF are not true? Select 2. A. In multi-area OSPF networks, all non-backbone areas must have an ABR connected to area 0. B. Single area OSPF must use area 0. C. 2 OSPF routers with different process IDs can become OSPF neighbors. D. The OSPF area must be specified in the network command.
The OSPF area must be specified in the network command. Must be specified, yes. Is true. I think this is true also. I think that's true also. In multi-area OSPF network, all non-backbone areas must have an ABR connected to area 0. I think not true is A and B.
E. An ASBR connects the internal OSPF network to networks outside of the OSPF domain. And F. The OSPF process ID must match the area number. Pause the video to think about the answers. Select 2. The answers are B and F. Although it is common practice to use area 0 for single area OSPF, you can actually use any area. And the OSPF process ID does not have to match the area number. In fact, in multi-area OSPF, there will be multiple areas operating in a single process, so it's impossible to match the process ID to all area IDs. The other statements are all true. Let's go to question 2. Next, routers connected to the backbone area, which as I said before is area 0, are called backbone routers. This includes area border routers, by the way. So which routers in this network are backbone routers? Of course, this router is connected only to area 0, so it is a backbone router. It is a backbone router and an internal router, internal to area 0. This router is also a backbone router, on top of being an ABR. Same for this router and this router. They are both backbone routers and area border routers, ABRs. On top of that, every small change on the network, for example, a new interface that you connect an ABR to a maximum of 3 is an ABR. So remember that ABRs, area border routers, are routers with interfaces in multiple OSPF areas. One more bit of information about ABRs. ABRs maintain a separate LSDB for each area they are connected to. It is recommended that you connect an ABR to a maximum of 2 areas. Connecting an ABR to 3+ areas can overburden the router. So a design like I show here is good OSPF network design, with each ABR only connected to 2 areas. Next, routers connected to the backbone area, which as I said before is area 0, become OSPF number.
In multi-area OSPF network, all non-backbone areas must have an ABR connected to area 0. All non-backbone areas must have an ABR area border router connected to area 0. Yes. 2 OSPF routers with different process IDs can become OSPF neighbors. Apa ini cuk? Filter. Cek. Bisa anjir. Cek 1 2 3 cek. Cek 1 2 3 cek. Cek 1 2 3 cek 1 2 3 cek. The OSPF process ID must match the NAS area SBR ini apa? Oke. NASBR connects the internal OSPF network to network outside the OSPF domain. The OSPF area must be specified in the network command.
Are all true. OSPF on R1's G01 and G0.
You want to activate OSPF on R1's G01 and G02 interfaces with a single command. G01 IP 10.0.k/28/26. Which of the following commands should be used on R1s? Router OSPF.
Pause the video now.
Network 10.0.12. For the /28 meaning 254/28. /28 you will use 25. Sumpah nggak ngerti aku anjing. 28.15. With a single command. So for the single command, we will use 10.0.12.0 0. Ini anjing.
To look at the commands and find the correct answer. The answer is C. Network 10.0.12.0, 0.0.1.255, area 0. This is the only option that contains both IP addresses in its range, so it's the only one that activates OSPF on both interfaces. Let's go to question 3.
Oh, kalau survive for minus 1. Paling all of everything else is 1. Kalau 254 berarti hmm, hmm, 255 itu ya. Ya ini kan vary.
Answer the following questions about the OSPF network below. 1. How many backbone routers are there? 2. How many ABRs are there? And 3. How many ASBRs are there? Pause the video now to answer each of these questions.
How many backbone routers are there? There are 1, 2, 3, 4 backbone routers. How many ABRs are there? ABRs are 1, 2, 3. How many ASBRs are there? So the ASBRs is just 1.
Routers are backbone routers because they all have at least one interface in the backbone area, area 0. Now, how many ABRs are there? There are 3. These 3 routers have interfaces in 2 separate areas, so they are ABRs, area border routers. Finally, how many ASBRs are there? Just 1. This router here connects the OSPF network to the internet, and likely advertises a default route into the OSPF domain. Let's go to question 4. Which of the following commands will make R1 an OSPF ASBR? Here are the options: A, B, C, and D. Pause the video to look at the options and select the best.
I think the answer is B, because you will configure the IP route to the internet. So it means you route the traffic of your internal network to your internet IP, so it's external, so it's gonna match the ASBR preference. So I think the answer is B.
Answer is B, which first configures a default route and then advertises it into OSPF using the default information originate command. Option A simply configures 2 network commands which activates OSPF on the specified interfaces. Option C activates OSPF on all interfaces with an IP address, since all IP addresses match 0.0.0.0/0. Option D is not a real command. Let's go to question 5. Which command can be used to manually configure the OSPF router ID? Here are the commands: A, B, C, and D. Pause the video to examine the commands and select the correct answer.
The answer is A. It's different from the
correct
EIGRP command to manually configure the router ID. So for the EIGRP, you will use EIGRP router ID, continue with the router ID, but for the OSPF command, you only use router ID and the ID.
Answer is A, router ID 1.1.1.1, entered in OSPF configuration mode. The command to manually configure the EIGRP router ID is EIGRP router ID, but for OSPF, it's just router ID. Option C configures an IP address on a loopback interface. If the router ID isn't manually configured, this IP address might become the OSPF router ID, but it's different than manually configuring the router ID. That's all for the quiz. Now let's do a bonus question from Boson XSIM for CCNA. Okay, here's today's Boson XSIM practice question. You administer the OSPF network above. You issue the default information originate command on router A. Which of the following statements are true? Select 2 choices. A, OSPF will advertise router A's gateway of last resort. B, router A will become the OSPF ABR. C, OSPF will summarize all of router A's directly connected routes. D, router A will become the OSPF ASBR. And E, OSPF will redistribute all of router A's directly connected routes. Okay, so pause the video here to think about your answer.
I think the answer is I think the answer gonna be router A will become the OSPF ABR. ABR ANA maybe, I don't know. ABNA.
Okay, so let's check the answer. So there are two choices. We use the default information originate command, which we just covered in this video, as well as the previous video on RIP and EIGRP. So what this command does is it advertises the router's default route into that routing protocol, OSPF in this case.
Oh,
So
the
that means
A.
A is one of the correct options. OSPF will advertise router A's gateway of last resort. That is the default route. Okay, next,
A
it's either
or
B or D
I think
is
D.
the second correct choice. Will router A become the OSPF ABR, or will router A become the OSPF ASBR?
ASBR.
So an ABR is an area border router. It is an OSPF router that has interfaces in two separate OSPF areas, usually area 0, the backbone area, and one other area. Now an ASBR, Autonomous
ABR.
System Boundary Router, is an OSPF router that is connected to an external network outside of the OSPF domain, and it shares information into the OSPF domain about those external networks. So that makes D the correct answer, because this default route is probably a route to the internet, for example, and router A advertises that default route into the OSPF domain.
So for the connection and configuring the OSPF, you must configure OSPF on a main or the parent or the mother router. So when you configure on that interface, as example, you configure the default route. I think yeah. Configure default route. You will issuing the default originate command in that interface. So in this case, router A will become the OSPF ASBR, or the, I don't know. So when you configure OSPF, you have to configure to its route that brought to the internet or the main router.
So let's check the answer. Click on Show Answer down here, and we are correct. So this is Boson's explanation of this question. Not only why A and D are the correct options, but also why B, C, and E are incorrect.
So it says open shortest path first, or OSPF will advertise router A gateway of last resort, and router A will become an AS boundary router. AS autonomous system boundary router, or ASBR. If you issue the default information originate command on router A. The default information originate command configure OSPF to inject a router's default external route into OSPF. Additionally, if you issue either the default information originate command or a redistribute network command in OSPF router configuration mode, Cisco iOS automatically considers the router an ASBR. An ASBR redistributes routes from other routing protocol into the OSPF domain. If router A in this scenario were configured with the IP route command, and a traffic distinct for a network that is not in router router's A command, router's A routing table will be forward through the FA01 interface on router A. However, if OSPF does not redistribute or advertise the default route on router A, neither router B nor router C will be capable of forwarding traffic to a destination address that does not have an associated path into the routing table.
So pause the video here if you want to read Boson's explanation. In addition to Boson's explanation, there is a reference here to Cisco documentation. OSPF command reference, default information originate. So Cisco's documentation is a really great study resource. If you ever have any doubts about some certain topic, I recommend doing a Google search, and Cisco's documentation often comes up.
So for this, we already continue we're already finishing this lecture for the OSPF. We will try to solve the lab, I think. Jeremy's IT lab, CCNA lab drive. Mana ya again? I think I'm gonna try to solve the lab for myself without watching the video. But first of all, I'm gonna import the flashcard and solve the flashcard first, and then we're gonna jump into the lab, OSPF lab part 1. .0/28 has no neighbor. First of all, I'm gonna import the flashcard and solve the flashcard first, and then we're gonna jump into the lab, OSPF lab part 1. Oh. Import. So we have the new due date. Gonna try to study and review. Configure the Ether channel load balancing method on the switch. Port port channel load balancing method. Route protocol or type IGRP, AGRP. Is this administrative distance berapa? protocol IGRP 170 100 IBGP internal BGP 20 200 anjing. What does intermediate system to intermediate system? OSPF AD 110 route protocol type RIP AD nya 1 berapa ya, 120 ya. GRP nah ini, in which dynamic routing protocol do all links have a metric cost of 10 by default? In which dynamic routing protocol do all links have a metric cost of 10 by default? ISIS. What is the name of the static route which has a higher AD than a route learned via dynamic routing protocol? What is the name of for a static route which has a higher AD than a route learned via dynamic routing protocol? Now, floating static route. What is single type of EGP path vector? What does BGP stand for? Border Gateway Protocol. Route Protocol ISIS AD-nya berapa? I don't know. 20, 15. Configure static route and specify DAD. IP route. IP route network subnet mask. Indo ID. IP route destination mask next hop. Next hop nih sini. Untuk destination. Tahu ya memang kalau next stopnya segini ya segini bikin, bukannya kita ada ya, bingung. IP route to the internet sebenarnya masnya juga segini, ini internet next stopnya ini.
The default information.
Beda-beda. Beda-beda. Mana kan? All time. I use a route. AD is to AIGRP external route. AD is one 20. EB. Directly connected 0, static route 1, internal EIGRP 90, OSPF 110, ISIS 115, RIP 120, external EIGRP 170, EBGP is 20. IBGP enter EIGRP configuration mode. Router EIGRP AS number. Enable EIGRP on interfaces in the specified range. Network network ID, wildcard mask. Prevent the router from sending EIGRP message on passive interface ID. Does the EIGRP AS number have to match between EIGRP neighbor? No. Manual. Desktop match. Modify routing information protocols AD on the local router. Stand. Configure the IGRP router ID. The IGRP router ID. Final configuration, highest IP on a loopback interface, highest IP in the physical interface, modify the number of paths RIP will perform EGMP load balancing over maximum path number. Disable EIGRP auto summarization. No auto. No auto summary. Modifier RIP's AD on the local router. Distance value. The IGRP will only perform unequal cost load balancing over unequal cost load balancing over equal cost load balancing unequal different routes. Visible successor route. The IGRP will only perform unequal cost load balancing over visible successor. Yes. Visible successor. Visible successor. Which EIGRP term this router's metric value to route destination. Visible destination, reported visible distance, reported distance. This router metric value to the route's destination. It's gonna be visible distance, I think. EIGRP visibility condition. The route is considered visible success if its visible distance is lower than the successor route's visible distance. Reported route is considered a visible successor if its reported distance. The route is considered a visible successor if its reported distance is lower than the successor route visible distance. The route with the lowest metric to destination, the best route. Successor. The neighbor metric value to the route's destination, reported distance. The route is considered visible successor if its reported distance is lower than the successor's route visible distance. The route is considered visible successor. Here's your default key values. K1 equals 1, K2 equals 0, K3 equals 1, K4 equals 0, and K5 is also equals 0. Okay. The GRP metric calculation uses the bandwidth of the GRP metric calculation uses the bandwidth of slowest link plus the delay of all links, which EIGRP term an alternate route to the destination which meets the visibility condition, visible successor. If an EIGRP route doesn't meet the visibility requirement, can't be used for unequal cost balancing. No. EIGRP will only perform unequal cost load balancing over visible distance or visible successor routes. Okay. The sure path first algorithm is also known as Dijkstra's algorithm. Which version of OSPF is usually used for IPv4? Um, there are three versions of OSPF as we knew. OSPF have the OSPF v1, v2, and v3. So for the OSPF v1, it's the old technology. It starts in 1980, but with OSPF v2, it's more like modernized IPv4 version of the OSPF, and OSPF v3 uses for IPv6 and extended IP or advanced practical on experimental use, but usually we use OSPF v2. Which version of OSPF is used for IPv6 is OSPF v3. What does LSA stand for? Link State Advertise. What does LSDB? Link State Database. Link State Database. OSPF are organized in a structure called the LSDB. OSPF LSAs are organized in a structure called the LSDB. OSPF LSAs have the default aging timer of I think 30 minutes. Yes, it's 30 minutes. OSPF can divide network into separate area. OSPF N is a set of routers and links that share the same LSDB. ABR, I don't know, area. The area 0 is an area that all other areas must connect to. Backbone area. The backbone area 0, is an area. Routers with all interface in the same area are called ABRs, rather than the same area. Internal routers, yes. Routers interface in multiple areas are called ABR. Check. Yes, ABR or area border routers. What does ABR stand for? Area border routers. And it's a set of routers and links that share the same LSDB. And it's a set of routers and links that share the same LSDB. Area. It is recommended that you connect an ABR to maximum of 2 areas. Routers connected to the backbone area area 0 are called ABR routers, backbone routers. Routers with all interface in the same area are called internal routers. And route is a route to a destination inside of the same OSPF area. And route is a route to a destination inside of the same OSPF area. ABR, I don't know, man. Intra area. Route to destination inside the same OSPF area. Intra area. And route is a route to destination in a different OSPF area. Extra route, I don't know. Inter area. Inter area. Enter OSPF configuration mode. RAR OSPF and process ID, I think. Yes, process ID. And route is a route to destination inside the same OSPF area. Inter area, intra, inter, and intra. Inter. Which version of OSPF is usually used for IPv4? V2, V2, Dijkstra's, link state database. LSIs, link state advertisement. 30 minutes. Area 0. LSDB. Area backbone router. Area border router. Area border router. It is recommended you connect an ABR to a maximum of 2 areas. The area 0 backbone. Routers connected to the backbone area or area 0 are called backbone. Routers where all interface in the same area are called intra router. Internal router. Internal router. Internal router. OSPF and is a set of routers and links that share the same LSDB. VBR. intra intra-array OSPF process ID inter-area yes. Okay, continue. We're already finishing the N key lab. The N key card, and then we jump into the lab, OSPF lab. Okay, wait a second, I'm gonna preparing my this one first. This manager. Okay. Configure the appropriate host names and IP addresses on each device. Enable router interface. You don't have to configure ISP R1. Enable router interfaces. Okay. So as you can see, we will assign all of these IP address and the host names first. And I start from R1's enable conf interface G00 IP address 10.0.12.1 255.255.252 no shot interface F10 IP address 10.0.13.1 255.255.252 no shot host name R1. Okay, finish on R1. Okay, R2. Enable conf interface G00 IP address 10.0.12.2 shot interface F10 IP address 10.0.24 1 2 host name okay. For the R3 10 IP address 10.0.13.2 shot interface F20 IP address 034.1 shot, and then the last one conf host name R4 interface F10 address 10.0.24.2 252 interface F20 IP address 10.0.34.2 252 shit. R3 udah aku ubah. Oh, belum. Oh, for the last one, for the interface G00, for the gateway to the PC1, IP address 192.4.254.4.255.0. No shot also. Configure loopback interface on each router. Interface. So interface L x0 IP address for the loopback interface. I think that's the appropriate commands to this one. R3 interface loopback 0. But it says configure OSPF on each router, enable OSPF on each interface, including loopback interfaces. Do not enable OSPF on R1's internet link. R1's internet link, so it's gonna be G30 to the internet ISP link. So we're gonna do passive interface for the G30. Including okay. Do not enable OSPF on R1's internet link. Okay, we're gonna try R1's router. Exit first. Router OSPF process ID 1 network.
Information originate command. So let's use the same network to, although it's only has basic OSPF configuration mode, you use the command router OSPF followed by a process ID. A router can run multiple OSPF processes at once, and this ID is used in the router to identify each of them. Typically, you'll just use a single OSPF process, so don't worry about this number. I chose to use 1. If you remember the EIGRP configuration, you use the command router EIGRP followed by an AS number. For EIGRP routers to become neighbors, their AS number has to match. However, the OSPF process ID is different. The OSPF process ID is locally significant. Routers with different process IDs can become OSPF neighbors. Usually, I just use process ID 1, but you could, for example, use process ID 1 on R1 and process ID 2 on R2, and they would still become OSPF neighbors and exchange LSAs. Note that this process ID is totally unrelated to the area. You'll see next that the area is configured separately. So next, I attempted to use the network command just like I did in EIGRP. Note that OSPF uses wildcard.
OSPF use wildcard mask. Network. Says here, do not enable OSPF on R1's internet link. Do not enable OSPF on R1's internet link. So it means I can advertise or use that network on this command, or I can use passive interface. We're not gonna configure the internet link. Network. Zero. Area 0. Ten dot 0 dot 12 dot 0 0 252 minus 3 2 0 0 0 3 30. Passive interface. OSPF. Process ID 1. Network. 10 dot 0 dot 12 dot 0 1 0 dot 0 dot 0 dot 3 area 0 10 24 20. Shit. Network. Network 10
Udah selesai bro.
Selesai.
Oke. Lanjut ya.
lanjut.
Langsung ini yang AI tadi. Bener mepet. Ini gua kan.
Ngapain nak?
Hah?
Sumpah guys.
Tulis.
Depan gibas. Depan hati. Gimana beneran jauh
Conf for the area no. Zero.
Masa gue dulu boy.
Area.
Masalah.
Area zero.
Salah. Ada sana nih. Wifi-nya?
Network 0 area 0 massive place
Makan. Sambil nonton Jojo bisa. Gue nggak ada foto tapi Shopee masih bisa pakai kan? Betul gak? Gue pede nggak ada foto lagi Shopee yang ada. Huruf kecil.
OSPF just ID1 network 10.0.0.0 area 0.
Di email.
yang 4. Configure R1 as an ASPR that advertise the default route into the ESPF domain.
Dan di email dikasih tahu sih ini kalau dikirim katanya diperingatin buat atas kumpulan ini dan segini gitu.
So we jump into the R1s first. To configure R1s as an ASPR on the default route. So first we have to route the default route to the static command. So the commands are IP route. We route all of this destination to this subnet mask into
Dari email lagi
203.113.0. So we route all this traffic, and it means all of the IP address in this range will come out to the internet. We can write in SD30. Right. Okay. We check the routing table. So we show IP route. It will flash receive.
nanti buat dia dua aktif dan dari siesta
Set into first P3 address 23
galon yang paling ujung
2.5. Ay. Two. Now show to enable the interface. So we see the show IP route. Ready to the static route to the internet. We're gonna advertise all of our connection and our configuration that we made on R1s, and make sure the R1s will be ASPR to connect to external internet. So the command that we use is default inform unrecognized command. Info OSPF1 information originate. Okay. We show up route. Look back. Reconnected because the look back is configured on R1s. This look back kan. Via this. Router directly connected. This routing table also. Yeah, this one. Already configured on static mode. For this one. Yes. SPF. Then this one do show IP route. Okay. Gateway of last result 10.0.34 round the network is on zeros. So we successfully doing this lab. Now we watch the video.
masks, just like. Welcome to Jeremy's IT Lab. This is a free complete course for the CCNA. If you like these videos, please subscribe to follow along with the series. Also, please like and leave a comment, and share the video to help spread this free series of videos. Thanks for your help. Also, remember to sign up via the link in the description to get all of the lab files for this course, so you can try it out yourself in Packet Tracer.
Oops. Di mana itu kalian beli?
Cani.
Bacot anjing. Kalian mau datang aku tadi, ke Bento kalian kan? Mau datang aku tadi. Udah datang kalian. Pas mau berangkat aku tadi.
Malam ya.
Ya pulang jam-jam ini, jam-jam setengah satu aja.
Ini jam 3. Bento jam 2.
Oh iya ya.
Bukan yang 24 jam. Bento.
Cuma 1 minggu memang harus begadang, Pin. Memang udah jadwalnya.
Iya.
Iya. Senin sampai Kamis baru.
Pasti nih jam-jam apa? Jam-jam
Game.
Malu dong kan? Bebas. Pas nggak foto. Nggak apa-apa. Yang penting pas foto namanya.
If you want more labs like these, I highly recommend picking up Boson's NetSim for the CCNA. Click the link in the video description to check it out. It's a network simulator like Packet Tracer, but it's even better, and it includes all of these guided labs to not only help you get hands-on practice configuring and troubleshooting, but also deepen your understanding of the exam topics. I used it myself when studying for my certifications, so I feel confident about recommending it to all of you. If you want to get your own copy of NetSim, please follow the link in the video description. In this lab, we'll do some basic OSPF configurations in this small network. This is very similar to Day 25's lab, EIGRP configuration, with a few small differences. Let's get started. First of all, before recording this video, I already completed step 1. I want you to get some extra practice with the basics like configuring host names and IP addresses, but at this point in the course, I don't think there's any need to record myself doing it. So first up, I'll do steps 2 and 3 on each router. Step 2 is to configure a loopback interface on each router. As I have explained before, a loopback interface is a virtual interface in the router. It's not a physical interface. I'll give a brief overview of them in one of these OSPF videos, but basically they are useful in that they can always be in an up-up state, unlike physical interfaces, which can go down due to hardware failures, etc. Then, step 3 is to do some basic OSPF configurations on each router. I'll start on R4 and then work toward R1. First, enter privileged exec mode with enable. Then, conf t. Let's configure that loopback interface. Interface L0. Notice these messages indicating that the interface has come up as soon as I create the interface. IP address 4.4.4.4, 255.255.255.255. Let me check that it was created. Do show IP interface brief. There it is, and the IP address is 4.4.4.4. By the way, if you really want to make sure the subnet mask is correctly configured, you need to use a different command, because as you can see, the subnet mask is not displayed in the output of show IP interface brief. So let's use this command instead. Do show interface L0. Look here, internet address is 4.4.4.4/32. I like using show IP interface brief for a quick look at interfaces, but sometimes you might have to use other commands. Okay, now let's configure OSPF. Router OSPF, and I'll use a process ID of 4. Remember what I said in the lecture video. This process ID is only significant to the local router. The other routers don't care about it. Just to show that, I'll use a different process ID on each router, and you will see that they still become OSPF neighbors. Next up, let's activate OSPF on R4's interfaces. I think I showed you this trick in the EIGRP lab, but if you want to activate OSPF on all interfaces at once, you can do this. Network O.O.O.O, 255.255.255.255, area 0. That's configuring a range of O.O.O.O/O, which includes all IPv4 addresses. Remember that the network command uses a wildcard mask. So 255.255.255.255 is like a subnet mask of O.O.O.O. So OSPF is enabled on all interfaces. In real networks, it's recommended that you be more precise about which interfaces you activate OSPF on. I just wanted to show you that little trick for quickly setting up OSPF in labs. Now, we are also instructed to configure passive interfaces where appropriate. F10 and F20 are connected to routers, so we shouldn't make them passive. But G00 should be passive. Passive interface, G00. Not only G00, but loopback 0 also. Routers will send OSPF hello messages on loopback interfaces, even though they are connected to nothing. So, passive interface, L0. I'll take a look at some OSPF show commands when we get to R1, but for now let me quickly go through the configurations on R3 and R2. R3 next. Enable, conf t, interface L0, IP address 3.3.3.3, 255.255.255.255. Now let's configure OSPF. Router OSPF, and this time a process ID of 3. Let's try another way of enabling OSPF on each interface, specifying the exact IP address with a /32 mask. First up, F10. Network 10.0.13.2, O.O.O.O, area 0. Next, F20. Network 10.0.34.1, O.O.O.O, area 0. Finally, loopback 0. Network 3.3.3.3, O.O.O.O, area 0. Here on R3, there's only one interface we need to make a passive interface, loopback 0. Passive interface, L0. Okay, that's all for R3. Next up, I'll configure R2. Enable, conf t, interface L0, IP address 2.2.2.2, 255.255.255.255. Now let's configure OSPF. Again, I'll use a different process ID, but usually I just use process ID 1 for all routers. Router OSPF 2. I'll enable OSPF on both physical interfaces first, like this. Network
Apa nyo?
10.0.0.0, 0.0.255.255, area 0. Then the loopback interface. Network 2.2.2.2, 0.0.0.0, area 0. And let's make that a passive interface. Passive interface L0. Okay, that's all here on R2. Finally, let's move to R1. Enable conf t, interface L0, IP address 1.1.1.1, 255.255.255.255. Now let's configure OSPF. Router OSPF 1. So we are told we don't need to enable OSPF on the internet link. Why is that? Well, we are going to advertise a default route to the other routers later, but there's no need for them to know about this point-to-point connection between R1 and ISP R1. If R2 needs to reach a server over the internet, for example, it just needs to know to send the traffic to R1. There's no need to know what subnet is used for the connection between R1 and ISP R1. So we won't activate OSPF on the interface unnecessarily. I'll do each interface one by one. Network 10.0.12.0, 0.0.0.3, area 0. Network 10.0.13.0, 0.0.0.3, area 0. Network 1.1.1.1, 0.0.0.0, area 0. Notice that for each router, I configured the network statements a little differently. On R4, I used a single command to enable OSPF on all interfaces. On R3, I specified the exact address on each interface. On R2, I enabled the two physical interfaces with one command. Here on R1, I configured the network address of each interface. Just be aware that there is more than one way to enable OSPF on each interface. Okay, now let's make loopback 0 a passive interface. Passive interface L0. Before checking out some shell commands here, let's do step 4 and configure R1 to advertise a default route. First, I'll do default information originate. Currently, a default route isn't configured though, so let's exit and now configure it. IP route 0.0.0.0, 0.0.0.0, and set the next hop to ISP R1's G000 interface, 203.0.113.2. Okay, we're done with the configurations, so I'll use exit to return to privileged exec mode. First, let's check out show IP protocols. We've already covered the output of this command. I just want to highlight that the loopback interface's IP address of 1.1.1.1 became the router ID. And because we configured default information originate, it says it is an autonomous system boundary router, an ASBR. An ASBR advertises outside networks into the OSPF domain, such as when R1 advertises a default route to the internet into the OSPF domain. Now let's look at a few OSPF specific commands. I will cover these in detail in the next few videos, but here's just a preview of them. First, to view the link state database, LSDB, use this command, show IP OSPF database. Here you can see all of the LSAs in the LSDB. Notice there are a few types displayed: router link states, net link states, and type 5 AS external link states. I'll talk more about these in the next video. Here's another command to view R1's OSPF neighbors. Show IP OSPF neighbor. As expected, R2 and R3 are listed as OSPF neighbors. And one more command, show IP OSPF interface. You can specify an individual interface if you want, or just view all interfaces. This gives details about the current OSPF settings on the interface, such as the various timers OSPF uses. Feel free to look around at the output of these commands if you want, but I will explain their output in a future video. Just wanted to make you aware of them. Finally, let's do step 5. Check the routing tables of R2, R3, and R4. What default routes were added? Let's check R2 first. Do show IP route. The default route is down here via 10.0.12.1, which is R1 as expected. Now let's check R3. Do show IP route. Okay, R3's default route is via R1, 10.0.13.1. Now let's check R4, and you might see something a little unexpected. What do you think the next hop of the default route will be? R2 or R3? Note that the connection between R1 and R2 is a gigabit Ethernet connection, while the others are fast Ethernet. Since I already taught you that OSPF uses interface bandwidth to calculate the metric, you probably expect the path via R2 to be preferred, and expect that it will be the only one entered into the routing table because of a lower metric value. Let's see. Do show IP route. Well, it looks like both routes have been added, so R4 will load balance over both paths. Why is that? Well, I will explain that in future videos. But if you want to do some independent research, try to find the answer yourself. If you think you know the answer, post it in the comment section. Okay, so in this lab we did some basic OSPF configurations in this network, including passive interfaces and advertising a default route. That's all for this lab. Now let's check out a bonus lab in Boson NetSim for CCNA. Okay, for today's Boson NetSim lab preview, we're going to take a quick look at this lab here, planning and configuring single area OSPF. Here is the lab topology. There are 4 routers. Routers 1 and 3 and 2 and 4 are connected with fast Ethernet. But routers 1 and 2 and 3 and 4 are connected with a serial connection. And as it says here, it is using frame relay as the layer 2 encapsulation. So frame relay is a layer 2 encapsulation, like Ethernet, but it's used on serial connections. Now some other options for serial connections are PPP and HDLC. Now in the current CCNA, you don't have to know these in depth. I will mention them briefly in these OSPF videos, but the main focus is the Ethernet layer 2 encapsulation. Okay, down here are the commands you need to know to complete this lab, the IP addresses on each device, and then the lab tasks. So this lab is divided into 4 main tasks: verify initial configurations, plan for OSPF, configure OSPF, and verify OSPF. So in the first OSPF video, the first lecture video, I only covered the absolute basics of OSPF. So we're not actually ready to complete this whole lab. But that's okay, we'll just do task 1 and a little bit of task 2 so you can see what this lab is like. And if you want to try it out yourself, you can get a copy of NetSim from the link in the description and try it out yourself here in NetSim. Okay, task 1, verify initial configurations. Step 1, verify the IP address and state of each interface on each router. So I'm already in the CLI of router 1, so let's check here. Show IP interface brief. Let's check with the IP addresses table here. Serial 0, 10.1.0.1, looks good. Fast Ethernet 01, 10.0.0.1, looks good. Okay, and they are both up and up. Now let's check out router 2. Open router 2, click here on the right side under devices, and click on console. Okay, serial 00, 10.1.0.2 looks good, and fast Ethernet 10, 10.2.0.2. Okay, and they are both up and up. Next, I'll check out router 3. Okay, serial 0 is 10.3.0.3. That's correct. Fast Ethernet 10, 10.0.0.3, and that is correct. Okay, and finally, I'll check on router 4. Okay, 10.3.0.4 is good. 10.2.0.4, that is good also. Okay, so all of the IP address configurations look good, and the interfaces are all up. Okay, next, step 2, I'll try some pings. So first from router 1, I'll try to ping these two interfaces, this one on router 3 and this one on router 2. Okay, so I'll go back to router 1, ping first router 2's serial 00 interface, 10.1.0.2. Okay, looks good. And next, router 3's fast Ethernet 10 interface, 10.0.0.3. Okay, no problem. And then step 3, from router 4, ping router 2's fast Ethernet 10 interface and router 3's serial 00 interface. So I'll ping these two interfaces here. Okay, I'll go on to R4 again. Ping 10.2.0.2, that is router 2's fast Ethernet 10. Okay. And router 3's serial 00. Okay, all looks good. So the initial configurations are fine. All the interfaces are up, and they can all ping each other. Next, task 2, plan for OSPF. All 4 routers should be members of the backbone area. What is the area ID of the backbone? So as I said in the last video, the backbone area is area 0. Now for single area OSPF, you don't actually have to use area 0, the backbone. You can use any area number, area 1, 2, 3, 4, 5, whatever number you want. However, generally, it's recommended that you use area 0 for single area OSPF, and that is one of the requirements of this lab. Okay, step 2. Your configuration should be specific enough so that as additional networks are added to the router, those networks are not automatically advertised. Okay, so we have to be specific with our network statements. We can't use the trick I showed you earlier, network 0.0.0.0, 255.255.255.255, to activate OSPF on all interfaces. We should be specific about which networks we want to advertise. Okay, the IP routing tables on each router should be populated with the specific IP subnets in your network. Using the IP addresses table, list the specific networks and masks that should be configured to satisfy this requirement. So, we should configure the specific subnet on each interface. So all of them are /24, as you can see. So if you want to know the network address, just change this last number to 0. So for example, on router 1, there is 10.0.0.0/24 and 10.1.0.0/24. Router 2 has 10.1.0.0/24 and 10.2.0.0/24. Router 3 has 10.0.0.0/24 and 10.3.0.0/24. And finally, router 4 has 10.2.0.0/24 and 10.3.0.0/24. So those are all the subnets. Okay, so that's step 2. Step 3, list the OSPF network commands necessary to accomplish the configuration requirement in the previous step. Okay, so we'll configure the network statements I just said, but you have to make sure to use a while mask. So the /24 would not be 255.255.255.0, it would be the inverse, so 0.0.0.255. So just to show you the commands that you would use on each router, let's look at the lab solutions down here. And here they are. So for example, on router 1, network 10.0.0.0, 0.0.0.255, area 0, and then the same for 10.1.0.0. And you can check on router 2, 3, and 4 as well. Okay, now from step 4, it talks about some aspects of OSPF that we haven't covered yet in the last video. For example, DR, that stands for Designated Router, which is an important topic in OSPF, and I will cover it over the next couple of videos. So I'm going to end this lab preview here. If you want to try this lab and all these other OSPF labs out yourself, make sure to get a copy of NetSim from the link in the description. Before finishing today's video, I want to thank my JCNP level channel members. Thank you to Florian, Dylan, Venkatesh, Pony, Joshua, Jilmar, Samil, Ed, Value.
Baling-baling biru, baling-baling bambu.
Welcome to Jeremy's IT Lab. This is a free